Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So today I want to discuss about the question bank related to this deflection of beams. So deflection of beams already we have covered in the theory part, and also we have seen some problems. In this deflection of beams, we have to calculate the slope and deflection of various beams. So already the types of beams, and then whenever these beams are subjected to some forces, loads, you should calculate the slope. And here at the end of the course, the student should be able to demonstrate the slope and deflection of various beams. So this is the outcome of this deflection of beams. The slope and deflection. So these questions are the selected questions taken from the question bank. So how to attempt the given question when he is asked the slope and the deflection calculation. So in this problem, a simply supported beam of span 3 meters is subjected to a central load of 10 kilonewtons. Find the maximum slope and deflection of the beam. So here I is given 12 into 10 to the power of 6 mm square, and E is 200 gigapascal. The simply supported beam, length given 3 meters and subject to a central load of 10 kilonewtons. And what he has asked, slope and deflection. See, the solution is, so the given length is 3 meters. The central load is 10 kilonewtons. 10 into 10 to the power of 3 newtons. The moment of inertia is 12 into 10 to the power of 6 mm to the power of 4. And the modulus of velocity value E given 200 gigapascal converted into mm square. 200 gigapascal, 200 into 10 to the power of 8 Newton per meter square, and then convert into mm divided with 10 to the power of 6. So we will get into mm square. So 10 to the power of, so 2 into 10 to the power Newton meter square, and mm square. So you are wrong. 1 Pascal is equal to 1 Newton per meter square. So in mm square to 10 to the power of 9 Newton per meter square by 10 to the power of 6 converted into mm square, you will get 10 to the power of 3. So megapascal, 1 megapascal is equal to 1 Newton per mm square. Okay, the maximum slope of the beam. We know that the maximum slope of the beam, so already we have covered in theory part the slope equation, WL square by 16 EI. So for this questions, only you have to apply those formulas, whatever you learn. WL square by 16 into EI. So the given W 10 into 10 cube into 3 into 10 cube whole square, and 16 into 200 into 10 cube into 12 into 10 to the power of 6. So you got 0.0023 radians. So this is the maximum slope of the beam. Which type of beam? The given beam is simply supported beam. So whenever the beam is subjected to forces or the acting central load at its end, the beam is bent like this. So this is y max, the deflection, and the slope met A and B. So theta A and theta B. Clear? So now the maximum slope of the beam, WL squared by 16 EA, the maximum deflection of the beam to find out. So WL cube by 48 EI. So the deflection for simply supported beam. So slope is WL squared by 16 EI slope and deflection for simply supported beam WL cube by 48 EI. For simply supported beam. The question number 2. A wooden beam 140 wide and 240 mm deep has a span of 4 meters. So determine the load that can be placed at its center to cause the beam a deflection of 10 mm. So in this, deflection given. So that cause deflection, what is the load? So take E is 6 gigapascal. So in previous problem, he has asked find the maximum slope and deflection in question number 1 model. So you have to apply the formula. For this second problem, somewhat different with the first problem. The wooden beam sizes are given and load is asked. So which type of load? That load can be placed at its center and cause the beam deflection, 10 mm deflection occur. See the given data: width 140, depth 240, span 4 meters, 4 into 10 cube mm. So center deflection 10 mm. And the modulus of velocity E is 6 gigapascal. So 6 into 10 cube Newton per mm square. So already we know the conversion 10 to the power of 9 Newton per meter square divided with 10 to the power of 6, you will get in mm square. So now the solution for the second problem, the moment of inertia not given. So for rectangular section, this is B and D. B and D. So this one also. So what is the I? The moment of inertia BD cube by 12. So B given 140 and diameter depth also 240. So substituting this, you will get moment of inertia. So and deflection of the beam at its center, at center point C, deflection already given the 10, but you don't know the load. So WL cube by 48 EI and W you need to calculate. So 7.25 kilonewton. Obtained the load is, after simplification, you will get 7.25 kilonewton. Next in problem number 3, question number 3. is simply supported beam AB of span 5 meters is carrying a point load of 30 kilonewtons at a distance 3.75 meter from the left hand A. So here what he has asked in this question, calculate the slopes at A and B and deflection under the load. So first diagram RA and RB, the reactions at point A and B. The AB span given 5 meters, carrying a point load 30 kilonewtons at not at its midpoint, at a distance of 3.75 meters from the left hand A. From left hand, here 3.75, and at what is the distance, so you can keep C point here 3.75 left the left hand. The point load is acting. So what is this? How much the load? 30 kilonewtons. Calculate the slopes at A and B. So what is the slope at A and B? Whenever this beam is deflected, deflection under the loads. So here EI directly given. So that is flexural rigidity. EI is equal to 26 10 to the power of 12 Newton per mm square. Now apply formulas and calculate. The given span L 5 meters, the point load already shown in this drawn diagram. The slopes are theta A and theta B. We don't know. And deflection also he has asked. So at C point, YC. So the distance between point load and left hand A, 3.75 meters. The distance between point load and right hand B. So what is the distance for right hand B? So total is 5. 5 minus 3.75. You will get 1.25 meters. So that is 1.25 into 10 cube mm. And flexural rigidity given 26 into 10 to the power of 12 Newton per mm square. So slope at A, we know that the formula IA or theta A, W into B upon 6E I into L square minus B square. So the W is 30 into 10 cube into 1.25 into 10 cube B divided by 6 into 26 into 10 to the power 12 and 5 into 10 cube. And L square, L is 5 into 10 cube whole square and B is 1.25 10 cube. So now calculate, simplify this equation. So we will get the theta at A point is 0.00113. Similarly calculate at B point. Whenever this beam is subjected to center load, so deflected, and then at the same time So the angle of twist, the angle. So what is the theta, the deflected angle at their ends, right hand and left hand. So already we have calculated left side. Now the second side, the slope at B, WA into 6EIL into L square minus A square. But in the previous, WB, so in IA, WB by 6EIL into L square minus B square. If you are calculated slope at A, you take the distance from right side, B. We are calculating the slope at B point, need to take A. That is the left side. One is right side and another and one is left side. Now substitute all values. Already you know A value, EI also given, the flexural rigidity EI, and L also given, A also you know. So substitute those values, you will get the slope at B point, 0.00158. Now find out the deflection. The deflection under the load. The point load is the given point load. How much given? The point load 30 kilonewtons. So what is the deflection under load? Means 30 kilonewtons. Deflection under the load, WB by 6EI into L into L square minus A square minus B square. So here WB into A also will add it. So substitute all values, W you know, B value and A value also you know, and then L square, B square, A square and B square. So we will get the deflection under the load. So 1.69 mm will get. Clear? So like this need to attempt the given question in the examination. Next question number 4. In this, what he has asked, directly asked, determine the slope at the left support. Deflection under the load and maximum deflection of simply supported beam of length 5 meter, which is carrying a point load of 5 kilonewtons at a distance of 3 meters from the left end. So E is 2 into 10 to the power of 5 Newton per mm square and I is equal to 1 into 10 to the power of 8 mm square, mm to the power of 4. So here the slope at the left end. So here not given diagram, the simply supported beam length 5 and which is carrying point load 5 kilonewtons from the distance of 3 meters. So you have to draw the simply supported diagram A and B. Under the load, the length is 5 meter and the distance of 3 meters from the left. C 3 meters and 5 kilonewton point load. The distance given 3 meters. So already mentioned here. Okay. The total is 5. Given length 5 meter given. So the remaining is 2 meter. So now the given length 5 meter and point load 5 kilonewton and distance between the point load and left hand support, that is 3000 mm, the 3 meters. So the B is L minus A. So A is 3 and B is 2. So total length is 5. So that you can write L is equal to A plus B. So now calculate the distance between point load and left hand side load. So the E given 2 into 10 to the power of 5 Newton per mm square, and mass moment of inertia 1 into 10 to the power of 8 mm to the power of 4. Let's slope at the left support. YC, deflection under the load, the maximum deflection. So deflection under the load, and then the maximum deflection, calculate. So using this equation, you will get the theta A, slope at support A, and similarly deflection under the load. So using this equation already we have covered in the theory part. Theta A is equal to W into AB by 6A into L into A plus 2B. You know the A value 3000 mm and B value 2000 mm. So EI is 2 into 10 to the power of 5 given, and L also mentioned. The L 5000 5 meters, so 5000 mm. So negative sign means that the angle made by the tangent at A is anti-clockwise. What is the deflection? WA square B square by 3EI into L. So W is equal to 5000 into, so 5 kilonewtons, convert into newtons, into A value and B value and EI and L. So we will get 0.6 mm. So this is the deflection under the load. But in the problem, in the question, so slope at the left support calculated, deflection under the load also come. Now maximum deflection of a simply supported beam. So they at C point already calculated. But what is the maximum bending moment? Deflection. E value, you know, and MI also, you know, and let's slope at support theta A and theta YC also calculated. Now the maximum deflection. So what is the maximum deflection formula? Y max W into B 9√3 into EI into L into A square plus 2AB to the power of 3 by 2. So now substitute all values, you know, W, A and B and EI and L also, you know. So substitute in this equation, you will get the Y maximum. Here 5000 W and B value 2 meters. A 2 meters. A is 3 meters and B is 2 meters. L is 5 meters. So substitute, you will get, after simplification, the maximum deflection is 0.6173. But the previous calculation, the normal calculation, the deflection under the load, due to the load at C point is WA square into B square by 3IEL. By using this equation, we have calculated how much got 0.6. But here, see, compare these two values, which one is maximum. So they are calculated by using this formula. Y max is equal to 0.6173 mm. In previous slide, you have calculated at point C, that is YC, deflection at C, 0.6, which is maximum. The maximum is 6173. So for this load, for this 5 kilonewtons load, the simply supported beam will deflect up to 0.6173 only. That is the maximum limit. So beyond this deflection, there is no failures. So up to 3 kilonewtons, the permissible, the allowable deflection is 0.6 mm only. The 0.6 mm giving the deflection means they will stand 5 kilonewtons. But maximum, the ultimate point, suppose if you are keep on increasing the load, what will happen in stress strain diagram? Already we have studied in first unit, first module. After the ultimate stress, the component will fail. So it can withstand only the maximum limit. That is allowable and working or design. So here also the maximum deflection, it can give this beam 0.6173 mm only. Okay, so for this, the maximum deflection, you need to remember this formula for simply supported beam. For normal, the maximum deflection, but the under the load, the deflection is WA square B square by 3AEL. 3EAL. So only need to difference here maximum and here the normal deflection. See, so like this we need to attempt the deflection of beams questions in the examination. So here I have taken only simply supported beam. So other beams also there. So calculate slope and deflection. Take more questions from the question bank and do those problems in the same manner. Apply the formulas and verify your solutions. Clear? So for this PPT, I have taken references some Ramamrutam, and the title of the book is Strength of Material, and R.K. Bansal, Textbook of Strength of Materials title, and Lakshmi Publications publishers, and R.S. Kurmi and Gupta, the Strength of Material. So SN and Co publishers. So these are the references I have taken for this question bank PPT. So you also take any one reference for further more clarification. Do number of problems. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.